We now have Katherine Hankinson from the UWA School of Biological Sciences. GotRhythm, how a music motor therapy app can change our brains and the way we move. Thank you, Katherine.
Thank you. Hi everyone. So today I'll be discussing the results of a recent study I conducted, which was looking into the effect of a novel music motor therapy app on human movement and brain excitability. So neuroplasticity is the amazing ability of the brain to adapt its structure and function in response to environmental inputs, experience and injury. So it's strongly associated with the acquisition of motor skills and motor learning. And it's also now known that spontaneous neuroplasticity will occur after neurotrauma and during neurological disorders. So the aim of current rehabilitation therapies after injury to the brain or to the central nervous system is to capitalise on this spontaneous neuroplasticity after injury and use motor learning to induce robust neuroplasticity to facilitate motor recovery. However, implementation of these techniques is often quite difficult, as people will find therapy often tedious, resource intensive and quite challenging. Moreover, patients will often be unable to initiate or maintain therapy due to a severity of injury or older age. So therefore there is a great need to develop novel rehabilitation techniques that can harness this beneficial plasticity while overcoming the issues associated with the current therapies. And so one of the ways we can do this is with music, by introducing music into therapy. And a recent discovery in rehabilitation research was the use of music to facilitate motor recovery. And this was a fascinating development because we can find out we can use music to change the way we move. So a specific protocol of this music therapy is called rhythmic auditory stimulation, which is the protocol I use in my current study. And RAS has been shown to be quite effective in a number of different clinical populations. And this is because evidence demonstrates that just passively listening to music will activate a widely distributed number of networks in the brain. And there are also richly distributed networks between auditory areas of the brain and the motor areas that these music therapies take advantage of to facilitate movement. And while this music therapy has been shown to be effective to assist with the recovery of movement, we believe we could improve upon this therapy by integrating this therapy with technology. So my team at UWA has developed a novel mobile software application called GotRhythm that incorporates personalised music, wireless wearable sensors, and real-time biofeedback to deliver this tailored RAS therapy to clinical populations. And hopefully this will work. Quick demonstration. No. That's right. So this GotRhythm app will use music to change the beat of any selected music that anyone wants to listen to. So we can speed up or slow down music depending on the needs of a patient. And during a training session, people are required to move in time to the specified beat. So we can do this by using simple fine motor movements, just as tapping, or larger or upper whole body movements using the connected wireless sensors. And there is also an auditory feedback part of this therapy that uses a metronome to guide people to help them move. So the overall aim of GotRhythm is to introduce this as a longer-term intervention for people with neurotrauma to be used in the clinic and at home. So specifically, we're looking into people following stroke. But first, I need to assess the effects of this therapy in a healthy young adult population. So the first aim was to investigate the neurophysiological effects of how music and movement work on the brain, and also how this affects movement overall. So to measure this motor cortical activity and neuroplasticity mechanisms, I use transcranial magnetic stimulation, which is just a valuable and well-established method to explore and understand underlying physiology mechanisms in the motor cortex after motor training and therapeutic interventions. So TMS just involves applying a brief high-intensity magnetic pulse to the motor cortex, which can produce synchronous muscle twitch, and we can measure the size of that muscle twitch. So to determine whether this GotRhythm can induce changes similar to the motor training used in current rehabilitation therapies, I just used a standard motor training task which is called a ballistic motor training task. It just involves patients or participants abducting their thumb as fast as possible in time to a metronome and seeing if they can optimize their acceleration over a 30-minute period. Our GotRhythm task was a very simple task involving simple tapping to a beat of 120 beats per minute. 6 songs were individually selected for each participant to help them engage with the music. And we just wanted to determine whether their motor learning occurred by assessing whether their accuracy improved, so their tapping in time to the beat improved over the session. So I recruited 20 young, healthy participants, and so while this study wasn't directly measuring an older adult population, we were hoping that this would inform our results. These results would help us to introduce this app into clinic or rehabilitation programs. So just quickly, just an experimental design. So I had repeated measures where participants would come in over 3 periods, 3 sessions. They underwent all the conditions. And we took the baseline neurophysiological measures, and then the participants underwent their chosen condition. And then we had a post-time period where we would measure at 3 points, so immediately after, 15 minutes and 30 minutes. And this was just to map the changes, the neurophysiological changes after the therapy. So some results, we just found that just sitting still didn't lead to any changes, of course, in excitability or brain activity. We did see the slight trend from baseline, but there was nothing significant happening. So there was no significant changes after the motor training, the standard motor training task. So just the simple ballistic thumb abduction task didn't really lead to any big improvements in brain activity. But interestingly, we did find that using the GotRhythm task did lead to changes in cortical activity from baseline. So we found that participants who listened to music and moved along to that music did change their brain activity overall. So next I want to assess whether these neurophysiological changes translated into behavioural change. So as I mentioned, GotRhythm occurred over the 30-minute period. So we have these individual scores of the first block of training, which is 15 minutes, and the second 15-minute block. And this just depicts the amount of time these participants spent tapping accurately to the music. And as you can see, participants were quite accurate in keeping in time to the music, even though a lot of them had no previous musical background and no music training, so people can intrinsically keep in time to the beat quite accurately over the whole session. And just quickly, just with their motor training tasks, participants did learn to optimise their movements overall over the 30-minute period after the training. So from this first study, we can see that GotRhythm did lead to a change in motor cortical activity, indicating an interaction between music and movement in healthy adults. And so moving into my second study, I'm investigating how GotRhythm training could potentially influence both subacute and chronic stroke patients to see whether training while moving to music can change an injured brain. And we're hoping to use an optimized version of this novel GotRhythm app by using the wearable sensors, so attaching it to any body part that can move or that needs training. We can get people to train specific affected extremities while moving to the music. And we're hoping to see that with GotRhythm training, there'll be an improvement in both brain activity and changes to movement, which will hopefully inform us to eventually introduce this into rehabilitation programs in the future. So thank you very much.
Thank you, Katherine. Do you have some questions and comments before we head to lunch? Thank you.
Is it difficult to separate out, like, that social interaction might stimulate the brain activity, or the feeling of being cared about, like, it might just be the physical, like, how do you actually separate all that out?
That's what we haven't really managed to figure out how we can separate it. We're hoping that will actually integrate and help people to move better or to feel engaged with music. A lot of people have suggested that instead of just using this app by themselves, people could be community groups or different rehabilitation groups to help music and social connectedness to kind of engage that part of the brain. But yeah, I'm wondering that will definitely add to this therapy, that social connectedness, and listening to music and enjoying the therapy as well.
I think that's going to be really important to uptake. You know, what we found in our work is about social connectivity and use of new technologies, not the medical technologies, but if it is embedded in relationships where there's motivation and it is social, the uptake will be much better. So I would recommend that as your part of your next plan.
Yeah, thank you.
Just wondered if any work has been done with Alzheimer's patients regarding music as therapy, as the type of studies you're doing at the moment.
Yeah, so I'm not currently looking into Alzheimer's, but yeah, I would think that would be fascinating to use music in an Alzheimer's population. I think there are quite a lot of studies looking into that because it can tap into so many different things, listening to music. And even I've been working with the chronic stroke patients, and a lot of people request that music from their kind of younger years, and when they're in their prime, they listen to this music, and it really engages them a lot more. So I think that would be really interesting to look into.
Thank you very much, Katherine.